Okay, so what we could do, maybe to start, is we could kind of just talk about like general code cleanup, refactoring,
Yes.
and then we can get into the real meat of things.
Yeah. So currently, if you've been paying attention to the libvfio, we added support for Nix, and we are starting a process of cleaning up the code a little bit more, as you no longer will be required to have the full config or in the correct order. There are going to be a few issues in upgrading still, which we are focusing in a bit. Then we're gonna move arcd out of libvfio, and libvfio will be more or less treated as a library which you can import into applications.
Yeah.
Or
One of the things that I think we wanted to do with that was code samples. So obviously there's this problem where a lot of folks don't program in the NIM programming language, but the good thing is that it has export C pragmas. So in that scenario, because we can obviously just use the export C pragma, hopefully we can write code samples and see that kind of thing, do some basic functions like, okay, create pixel surface, here's a particular application binary interface that we want for a particular system. So like, we want Win64, we want a pixel surface of this dimension, and then we can get it like a binary and have it run in a virtualized state. So hopefully we'll have code samples for that eventually.
Yes, so that will be so the procedure of actually productionizing libvfio a bit more, as well as providing a refactor and a bit of code samples in different programming languages will probably start next week. We'll keep you guys posted on that. With the announcement of OpenRM, we are now working on making a version of the librm.
Do we want to dig into it?
Well, do you want to start this now?
Yeah. Probably dig into it at this point. So there's a couple things that we're obviously looking at with the RM driver. The first thing is obviously VGPD and VGP Manager are still closed source. So from a practical point of view, what that basically means is to this day, we still cannot produce the merge driver artifact with MIT and GPL sources. So effectively, that means absolutely nothing. The open sourcing for Cubes or OpenXT or any other project that wants to integrate and support. So obviously, there's some issues there. And the other issue is that anything that we're doing concerning a CI system. So we've got some things that we're doing where we generate on a fairly regular basis like these ISO files, and then what we do is we try to use those ISOs to keep like an archive of the software, and then we can do unit tests to check things, making sure that we don't have regressions, that kind of thing. But unfortunately, because the only we can include in that is GPL and MIT sources, the only thing we could ever really support for is Intel, and obviously they're not at a point today where we're ready to put out drivers. So that's kind of an ongoing concern. It would be great if we could get VGP Manager open source, because then we could obviously look at including that in the ISO. So the next thing I think we wanted to touch on is that we do plan on doing ArcGPUD as open source, but we're going to put some steps in front of us in order to do that. Did you want to talk about librm?
So the first step in open sourcing something like ArcGPUD and the GPU Manager or something similar to this is we need to have a way of communicating with the driver. Fundamentally, NVIDIA didn't open source capabilities to actually allow for interactions with the driver. They simply open source how the driver works internally.
Yep.
Our steps that we have to do internally first will be to actually recreate the interface layer that we can actually use to talk with this driver.
So what we're going to be doing is we're going to be releasing librm for two languages. So it's going to be Rust and Haskell. Haskell because obviously we do some rapid prototyping.
Yep.
And what we're going to do is we're going to encourage different stakeholders to contribute to the librm support. Once we feel confident that librm is sufficiently functional, our implementation of librm is sufficiently functional, Then at that time, what we're going to do is we're going to open source ArcGPU. So I think it's in everybody's interest at this point to try to get good support in librm, because obviously there's a variety of use cases besides just our own.
Yeah, perfect example is NVIDIA SMI. NVIDIA SMI is still close to a spinner, but they use it in order to get information on GPU statistics.
Right. Okay. So I think the only other real thing in a kind of structured way that we really do want to touch on is that, in terms of the way that, if you guys have been following it, all the mediated device internals documentation, there's some areas that still are lacking in terms of how that's laid out. So I think at this point we need everything to do with scheduling that's basically not there. We don't really have great explanations of how the MMU works. But yeah, there's a couple things in terms of how that works. So internally, there's that frame buffer interface API. That is pretty opaque. I don't think we have any clear explanations on how that works. And also there's the MMU config rights, which, as far as I can tell, we still have issues around how and when the configuration rights occurred. We don't know anything about that. We don't have, as far as I can tell, any way to list IO virtual addresses and how they're mapped to processes or RM client IDs. And the other major issue that I'm seeing here is there doesn't appear, as far as we can tell, to be any form of mandatory access control whatsoever to the GMMU configuration. So what that means in practice is like the kind of thing that I think Intel did, where they have Minix 3 microservices. So you have a service like, say, an audio driver, and then it has to talk to like a permission daemon that then says, okay, this daemon has permission to speak to like the ports required to do like, to make a sound come off the speaker. So there's some sort of mandatory access control where individual microservices have their capabilities defined by some, central privilege component or privilege management component inside of the embedded operating system. With the Falcon in the real-time operating system, it doesn't look like there's formal verification, which is a problem. As far as we know,
there's a little bit. It's
not done yet.
Yeah, not finalized.
And there does not appear to be any kind of mandatory access control whatsoever to that API. So what that means in practice is we don't know how it's been configured. We don't know when it's been configured. We don't know if it's obviously been configured incorrectly or properly or been maliciously configured. Or if a process were to, let's say, for example, get arbitrary code execution on the Falcon, what that effectively means is that you could abuse the configuration of the GMMU controller and break IO virtual address translation between shadow pages in the GPU VRAM. So what that means is a virtual machine escape that would be virtually undetectable because the platform only has visibility into the operating system running on it in the hypervisor. The internals of the GPU are a complete mystery. So honestly, what probably needs to happen there is somebody needs to, have a conversation internally about, can we implement some kind of mandatory access control on that API, or talk with us, and we could probably point them in the direction of some similar architectures they know what to look at in terms of what Intel did. Because at this point, I would be, if it were like a huge interest to me, I would be telling security researchers to go poke around there and see if you can get some virtual machine escapes to try to, demonstrate how bad of a setup that looks like it actually is.
Mm-hmm.
Okay. Did you guys, I think that's pretty much the full list of our prepared thoughts. Do you guys have anything you wanted to talk about? I guess we kind of just dove straight in and didn't really have an initial discussion with anybody.
Yeah.
Yeah. I mean, who we got here? We've got obviously Eric, Aaron from our community, Kenny from our community, X-Man, who I actually never seen before. I'm not sure who that is. Grand from the community, Demi from CubesOS. Hold on, let me get there. So ArcV is open source. We have support for, is that?
Lab, yes. So we are in the process of working on LibRM first and foremost, because we see a few more use cases than just in ArcD GPUD, which we will be working on. Our first steps here is to do more or less a formal verification approach, which in turn goes into the actual code. The main reason for this is because it still is kind of a black box, as we do not have any of the source code that is how they implemented it. So a technique that I've learned is you identify certain things from the open source component and you try to recreate the closed source in more or less a hidden model. We do not know what this model is. We just know that this component here takes these inputs and gives this type of output. If I switch these inputs and I get this type of output, this thing happens. And we've gotten past the initial prototyping stage as we have been able to create our own our own vGPUs, and even attach them for a brief moment into actual running QEMU process.
Yeah.
So the next step moving forward will be to actually scrap all that and use that more or less as we know this type of thing works. Let's actually make it work well and predictably for all future situations.
Yeah, that makes a ton of sense. The other aspect of this is because we're doing this in Rust, both for RTGPD and for librm, I think that pretty well everybody can acknowledge that that's a step in the right direction relative to how it currently is.
Well, we'll also be doing it in Haskell.
Right, but the librm aspect of it, yes.
Also likely gonna have the ArcD GPUD in Haskell before we will have it in Rust. And the main reason for this is one issue I have been facing with Rust is you have to play a game of I need to know the correct offsets. When I create a data structure, I have to say, okay, this, and then you have this pack macro or pragma, which allows you to actually say, is it packed, is it not packed? And you get a CLike API, but the CLike API doesn't allow me to say, this offset right here, I know this one is exactly this situation. I don't know what this one over here is. So the byte sizes that I get from Rust programs when I'm trying to do this type of prototyping has not been as fruitful as it has been in Haskell.
Okay, so I think that's a fair summary, but I think that as a point to say, like, for everyone involved, if the current implementation is in C and we're going to do it as open source in Rust, I think everybody could acknowledge it's basically a step in the right direction. So I think mutual support on that would probably be good for everybody involved.
But our first step will actually be librm docs that we will have linked on the OpenMDev wiki probably by the end of today. And there will be an org file and a few other things and initial work on actual formal verification of how we build a librm, an open source librm.
Yep. Okay, I think that makes a ton of sense. So yeah, the only other two folks that I think I mentioned everybody's here is Merrick from Cubes and VM Fortress. Do any of you guys have any questions with regard to the plan to do librm first and then to sort of progress to eventually open sourcing RTGPD? Got here a bit confused on what the purpose of librm is. Did you want to touch on that?
Oh, so librm is how you interface with kernel module. So if you looked at the open source NVIDIA code that they have recently open sourced, you will notice that they have mentions of something known as RM API.
Yeah.
So librm, when you also look in other areas of the code, is an interface layer that someone from a user space program can access and interact with running kernel module to actually perform certain tasks, such as allocating routes and modifying values inside those routes.
Yep, that makes sense. The only other thing actually is that now the VRM is actually in two places. So there's the GSP now, which contains parts of the resource manager, GPU system processor, and then there's obviously the stuff that runs locally. So the stuff that's actually inside of the open driver, and in reality, it's a shim with a binary blob in an external state. It's a lot more open than before, but clearly there's still a great amount that's not visible or clear to interface with.
Any recommendations as well? We are open to any recommendations that anyone here has.
Yep. So Demi, I'm curious, we had some lively discussion on the VPub not too long ago with regards to your thoughts on optionally enabling vGPU stuff on boot or an installation of cubes. And I was reading a little bit around Ian Pratt and his thoughts on why PCI device virtualization is a complete mess and how it's not really clear on how we can filter what might potentially be like a dangerous operation. And hence why they didn't implement it in like UZen or Zen by default. Did you have any particular thoughts on like what would necessary criteria be to effectively filter like dangerous PCI events, that kind of thing? I don't know if Demi is still here or not. What I could probably do then is I could probably speak to my surface level understanding of the existing strategy that's taken in at least OpenXT. So OpenXT, I believe, if my understanding is correct, there's two layers under which it was implemented. One was the legacy VRM surface manager, and then the other one was vGlass, which is the current implementation. Both of those basically treat. What is Merrick saying? Demi, are you trying to say something? We can't hear you. Yeah, we're not. Demi, if your microphone is, we cannot. Yeah, hear your mic currently. Yeah. Anyway, so the way that vGlass works, if I'm understanding, I'm not entirely sure about how Surface Manager works. I was muted in DOM0. Demi is running from Zen. The way that it works in vGlass is the idea that basically it treats everything that goes into the virtual machines as basically like a single requester. So you have on the host, or now the host in DOM0, a driver, if I'm understanding correct, that then handles all the requests to the GPU. And there's no splitting of the requester IDs into the GPU, so you're not really running in like a SRIOV mode or something like that. And one of the things, I think it's basically doing something similar to Virgil, where it's like sending serialized instructions to the host, and then the host is kind of the DOM0. I have to get that terminology out of my mind in Zen. And then DOM0 is executing instructions basically as if it were just different applications, not necessarily ones that were like running as discrete virtual machines or passing a PCI level function to just, basically Virgil. The thing that would be more sensible to do, in my view, probably has something to do with like we have something like different client IDs, kind of like how in the resource manager we can do IO virtual address translation by having a client ID registered to a process. So I think that applies to both SRIOV mode and the VFIO MDev. It's the same thing in both of those cases.
What?
You know how we get client ID and we do IO virtual address translation for all those?
Oh, yes. I'll explain that a bit more. The ways that it's currently implemented. The ways that it happens is internally, the VM knows that it's actually on a virtual GPU, and it actually will change slightly the RM IDs.
Right.
It's kind of like allocating something on the heap versus on the stack. On the stack, you're moving one way, and on the heap, you're moving the other way.
So I know in the context of the way that VFIO MDev works is that it's supposed to create a mappable region of memory. So it's like some region that gets passed through and some portion that gets emulated. And then those portions, the way that they do the map is done, I think, on the host. And then we pass that region to the guest, no?
So there's some form of sharing control,
Yeah.
from my understanding, where you can actually share regions of virtual memory between um, component A and component B if you actually have the client ID. So
So you mean like overlapping the shadow pages?
kind of, it's a little bit more interesting. What happens is, let's say we have GPU process 1 and GPU process 2. GPU process 2 says I want like some memory in the GPU. So the RM API allocates that memory in that GPU. And GPU process 2 then says, well, it can ask, can I have permission to actually have access to this region of memory that was allocated to this?
So one of the problems with the VFIO API, if I understand this correctly, is that it only works with page pinning at the moment. So if you map some memory on a device,
Yeah.
you cannot really do like swapping page in, page out, that kind of thing with the VFIO API. This is I'm talking about the
Yeah.
platform right now.
Yeah.
So at the platform layer, you have to do VFIO pin page. It's like
yes.
and then that supposedly maps memory where there's like an identity map into IO virtual addresses in the GMMU, right?
Yes. Kind of. It's a little bit weird because it was NVIDIA specifically. They have their own internal yeah.
NVIDIA VFIO KO, right? Which, by the way, is also not open source. So that's one of those things.
Yeah, and part of that is it actually translates command. So similar to what we were talking about earlier about how the VMs would be treated as unique applications. It does the same thing, but each application inside the VM is treated in its own unique way as well.
Yeah, no, that makes sense. The okay, so the thing though that my understanding is correct is that when we have these mapped pages in RAM, they're basically pinned, as in the memory is effectively not going to move around in RAM. That's at least the way that Red Hat guy wrote the VFIO API.
Yes, so they do not move around during the runtime of service.
RAM. But the way that it's implemented in VRAM, like with the shadow pages and IO virtual address translation, in theory, the shadow pages are supposed to be effectively an identity map on RAM, right?
Not exactly, because what happened is, so there's that portion, but then there's a few other portions of it. So that memory is allocated on the operating system. The operating system then decides, do we allow you to do this? Do we not allow you to do this? So they actually do the kind of memory management on more of a actual CPU level as opposed to on the GPU.
That's for the RAM. Okay, so another thing, we actually did have a question at some point. We were talking to somebody from Nimverge, which I think was considering coming and joining. What does Kenny have to say? Need to read the DMA book. Did you catch that?
How about me?
Did you want to open up the chat and read it? What did you say?
Yeah.
DMA buff import on NVIDIA so we can reduce copying it in the frame for the long run.
So this is what I was saying previously, where you have the resource manager and you ask the resource manager for that memory. So what we have to do is we have to create something known as a presenter plugin. I'm using terminology from Surfman on OpenXT. What has to happen?
Actually, the term they use.
They use that also in NVIDIA stuff. But what I'm saying, because it seems to have became a de facto standard some time ago. I could be wrong, of course. If I am, please correct me. Um, so what happens is these presenter plugins kind of serve as a virtual display monitor. When we were working with AMD and AMD GIMP,
Yeah, they don't have anything like that.
we needed to use VNC to actually accomplish this.
Yeah, it's part of their documentation. Call a VNC server in order to get a virtual display going.
So how NVIDIA ended up doing it is their resource manager actually allows you to say a block or a region of memory between the one that's available to the VM and the one that's available to the host. So then the host can take that and say it to another program. So in the
isn't that exactly the way that it's even the same with when we're dealing with actual monitors, right?
Yeah.
With the same virtual surface.
Yeah. So the way that we will eventually solve this issue is a new introspection option that we have planned in a few months or so. When we actually figure all of this out, will actually be similar to a looking glass, but as opposed to actually doing the spice or connection or anything like this, it simply asks, can I have access to this region of memory from the NVIDIA.ko? And then it's just a RAM read.
Yeah, that depends. One of the things that obviously we're going to have to be careful of is sharing driver memory.
This thing will be more or less be forced to if we use the NVIDIA drive as a base. If the only way we will be able to do this without this is if we do not use an NVIDIA drive as a base.
Well, one of the issues that we're going to have is that the VFIO API does not, at the moment, allow for, as far as I can tell, at least in RAM, with VFIO pin pages, there's nothing to do with shared memory or swapping or anything like that, page in, page out.
They are essential.
The guy who wrote it actually mentioned that was one of the major problems.
I'm looking into how the user space programs do it.
Maybe what in VFIO works, but like VFIO, the actual VFIO.
I'll show you what I mean.
Okay.
How you can do this.
The way that we're dealing with MMIO and RAM, I don't think we can do that.
There are ways. I'll show you. Yeah.
What was the other thing I was going to mention? Yeah, somebody at some point was asking about if we could actually do page in, page out on the host. It looks like you can do that in WDDM driver, the Windows driver. Like if we have a vGPU guest, we can swap to RAM in that scenario. So we could potentially, like we have a 4 gig vGPU in the guest, we could just say, okay, well, if you have RAM space to swap, then you can page in, page out to the GPU or to the MMIO space that you're dealing with. Whereas on the host, I don't think there's anything like that, precisely because of the issue with pinned pages with VFIO. So we could probably look at talking to the guy who did that API and see where the limitations are, and then what could we do potentially around how the internals are implemented to work around that issue. I think there's some interest on folks that are doing like interesting things with memory caching to really expand the amount of available memory to the GPU.
There's a few ways that way. We could talk with him, I think.
Yeah. Okay, that's something we could look into. Was there anything else we wanted to mention? Anything specific you can think of?
Not on my end.
Okay, that makes sense. Yeah, so I think with that, we'll probably consider the recorded portion of the call done. So I think the existing format, if you guys recall, is we do part of the call recorded and part of the call sort of unrecorded, so we can freely discuss things. So we'll cut that now, and the first half will go up as a recording. Everything from this point forward will be unrecorded. So if you guys have any questions you want to field before we wrap up the call, shoot them over and we'll try to answer them.
Yeah.
Eric, can you cut the recording? Thanks.